Firstly, we will start with sequence. A sequence is a function, where the domain is a set of consecutive positive integers beginning with 1. An infinite sequence is a function having for its domain the set of positive integers, 1, 2, 3, 4, 5, and so on. For example, 3, 9, 27, 81, 243, and so on. On the other hand, finite sequence is a function having for its domain the set of positive integers, 1, 2, 3, 4, 5, until reach n, for some positive integer n. An infinite sequence is often defined by stating a formula for the nth term, Tn. For example, let the nth term of a sequence be T of n equals 2n. Using the sequence notation, we write this sequence as follows. As you can see here, the first 3 terms, the T of n term and the 15 term can be seen in the sequence. Now, we will continue with series. Series is a sum of a sequence. As you can see here, the sum of the sequence of 1, 4, 9, 16, 25, and so on is called as a series. Series can be finite or in terminal form or infinite, which is unending. You can see clearly the example of both infinite and finite series through the example. Now, we will continue with arithmetic. An arithmetic sequence is a sequence in which each term after the first is obtained by adding a fixed number to the previous term. The fixed number that is added is the common difference and is denoted by d. The nth element of an arithmetic sequence is given by T of n equals a plus n minus 1, multiply with d where T of n represent the nth term. A is the first term and d is the common difference. If an arithmetic sequence has first term a and a common difference d, then the corresponding arithmetic series is given by Sn equal to n over 2 multiply a plus Tn. Or Sn equal to n over 2 multiply 2a plus n minus 1d. Now, we will look at geometric sequence and series. The definition of a geometric sequence focuses on a sequence in which each term after the first is obtained by multiplying the preceding term by a constant non-zero real number. 1, 2, 4, 8, 16, and so on, is an example of a geometric sequence, with first term 1 and the common ratio is 2. The general term of a geometric sequence can be seen here. Suppose a geometric sequence has first term a and common ratio r, the geometric sequence is a, followed by ar, then ar square and followed by ar cube and so on. Then, the nth term becomes ar power n minus 1. Therefore, the common ratio is r where t2 over t1 or in other word, the tn divided by t of n minus 1. Now, we will look further in geometric series. The definition focuses on sum of n which represent the sum of the first n terms of a geometric series with first term a and common ratio r, in which r is not equal to 1, then, we got these two sum of n. Please note that for r lesser than 1, the sum of n refers to a, multiply 1 minus r power of n, then divide by 1 minus r. On the other hand, for the case of r greater than 1, the sum of n refers to a, multiply r power n minus 1 divide by r minus 1. The relationship between T of n and sum of n is given by Tn equal to Sn minus 1. Sum to an infinite geometric series. For the case of sum of any infinite geometric series, with the condition of modulus r is less than 1, the sum s of all the terms in the series is given by s equal to a over 1 minus r. Let's consider this example. Let's say we are given the infinite geometric series, as shown here. The sum of the first n terms is given by sum of n which equal to 1 minus 1 over 2n, over 1 minus 1 over 2. As n approaches infinity, the 1 over 2n approaches 0. Then, sum of n approaches 2 which refers to sum to infinity. Now, by considering the geometric series of a, plus ar square, and so on, the sum of the first n terms are given by a, multiply 1, minus rn, divide by 1 minus r, for any r that less than 1. Now, it can be written as Sn equal to a over 1 minus r minus ar power n over 1 minus r. If r is between -1 and 1, then Rn approaches 0, as n approaches infinity. Therefore, Sum to infinity r, a, over 1 minus r for modulus r lesser than 1.